Welcome back to Autodesk Digital Builder Podcast. We are in Los Angeles at Greenbuild, and today we're going to be talking about decarbonization. And I think this is going to be a bit of a decarbonization 101 to start, just to kind of set the stage for what we're talking about. And then the second half, we're going to look at the future, technology, see where AI plays a role, and a whole lot more. To help me tell that story today, I'm joined by Jack Rusk, the CEO and co-founder of C.Scale. Jack, how are you doing this afternoon?
Eric, I'm stoked. Greenbuild's super exciting this year. Lead V5 is out. There's big changes coming, and you really sense the whole industry getting behind this vision.
Yeah, it's an electric moment here at Greenbuild, and I think we're all feeling good, and it's just such a good community where everybody's on the same page. You know, like we're feeling ready. So let's get into decarbonization and help folks understand kind of where we're headed today. So tell me more broadly, what exactly is decarbonization? What does this concept mean? And what typical actions are taken to realize some of these sustainability goals?
It's a good question because I think a lot of these terms are bandied about without a lot of specificity. And the nice thing about decarbonization, I think it's actually an asset that it can mean different things to different people. I'll give you an example. We're here today to talk about buildings and the built environment because that's where we spend our time.
Yep.
But you talk about decarbonization, and actually agriculture thinks about decarbonization. Transportation, right? Fisheries think about decarbonization. But I'm really excited about decarbonization of the built environment because of the way every building is like this node in this global network of energy and material and labor flows. And by working on creating buildings from cleaner materials using cleaner energy, which really is the core of what decarbonization means, we're able to catalyze these transformations globally exactly because buildings are this really integrative part of the global economy. So when we think about how people practice decarbonization, how people practice building with cleaner materials, materials that take less energy to produce, materials that can be produced with lower emissions energy, there's a couple important kind of characteristics to run through. The first and most essential one is just finding ways to build with less. There's been a big movement globally in the United States and beyond of focusing on adaptive reuse. This is both the kind of climate story people tell because you're able to make better use of things that have already been built. But the other really important part of adaptive reuse is also preservation and cultural story that people are able to tell. And I think these linkages are really important, that we aren't just decarbonizing buildings because we care about climate change. We also care about culture and people and the way all these things interact. So making better experiences and living spaces with less materials. And then you look at where the materials that we do use and the energy we use comes from, looking upstream. So there's been a lot of work in energy systems to make transitions to solar, to wind, to battery storage, either on site or on the grid. And that's really important for the energy supplies that feed into a building. And really where we spend a lot of our time is supply chains. Buildings are complex. Hundreds of materials are coordinated on site at just the right minute, right, to erect it. And if you think too much about that process, it seems impossible.
Oh, it's overwhelming,
right? No, really. And, I know you and like the broader Autodesk universe talks a lot about construction and how complicated construction is as a discipline. We touched just a little bit of this, but it's boggling, actually, what needs to happen for any of these buildings to come together. All those materials come from somewhere.
Yeah.
And by thinking serious about where they come from and how they're produced, we're able to take these positive impacts we make on the building site, better buildings for healthier people, and try to multiply those positive benefits upstream, where the materials are manufactured, the people manufacturing them. And really, decarbonization really is a lens that allows us to tie these outcomes on site to these outcomes throughout the supply chain.
And I think the core of a lot of this is just being very intentional. This stuff doesn't happen by accident, and it's complex. And when you start looking closely at the entire supply chain, like it's very easy to step back and go, okay, well, I'm the owner or I'm the general contractor. I've subcontracted with somebody to do the HVAC. So that's their concern. And so there's a lot of relationships that need to be built to be able to step down that supply chain as well, to get the visibility. And I think HVAC, I've been told, is a really great example of a bit of an unknown as far as the amount of carbon that goes into both the creation and then getting these assets to the facility. Because, an AHU is considerable in size, and a lot of these materials, they're shipping. Where are they coming from? Is it going to be shipped overseas? Are you going to fly it? How heavy is it? Like there's a lot wrapped up into it. But I also really like your adaptive reuse example and just the there's a human cultural element to decarbonization and in renovation. And I had a really wonderful conversation with Amr Rafat from Windover a couple of years ago.
Amazing.
And they did a lot of really cool laser scanning of a very old facility where they were able to recreate the facade that had been deteriorating and crumbling and reuse it with sustainable materials in a way that replicated what had been there before, but in a way that will last over time in a way than the original materials hadn't done. And that's just a small example, but it requires a lot of deliberateness, and it's not just a ground up building that this conversation needs to happen at. It's at all aspects of construction and renovation. There's a lot goes into it. There's a lot to be excited about, but I think also a lot to be overwhelmed by at the same time.
And a lot of this complexity that you're pointing at is really the bread and butter of practitioners across the built environment. And that's something that gives me a lot of hope and helps us be ambitious in our work, is that designers and people working in the built environment, contractors, aren't afraid of this complexity. They deal with it in every part of their job every day.
But can you imagine another example of having like 30 or 40 specialty contractors on a project site at the same time? They're all different companies. They all have different contracts, and they have to come together in a very tight time frame in a very small laydown area to build something magnificent.
And let's multiply that problem looking upstream at the supply chains and the energy systems. And what's really exciting to me about decarbonization as a frame is there's a lot of, we'll say, I think reasonable critique sometimes about carbon as a metric, because it really is one thing, it's not another. It doesn't capture things like material health, but it has this really important ability to put all of these activities on the job site, upstream in supply chains, the use of energy, in sort of like the same language, a common metric to be used across this so that we know that we're always focusing on what matters most. This is actually one of the magics of money, right? You're buying a taco in Los Angeles, you're buying pizza in New York, you're buying a air handling unit in Miami, Florida. It's all in terms of the same unit. Carbon allows us to do the same thing for environmental impacts.
I love
all
that
of these different, sorts of impacts on a common footing, so we can make sure that we're focusing on that big ticket items and not worrying about the smaller ones.
In the complexity of measuring everything, it's nice to have at least one data point that can be an even playing field, because everybody has different priorities, different ways of working, different ways of collaborating. And I think that central point that you bring up, it makes a lot of sense. But I want to come back to a point that you made about how a simple design, when we first met, that you made about how a simple design decision, like a new line drawn on a blueprint as an example, can have a considerable ripple effect on a project. Can you walk us through that sort of ripple effect and how or where it impacts carbon emissions?
Designers work at various degrees of abstraction. Maybe they'll plan a whole neighborhood or district, and they're planning it just with rectangles drawn on a map, right? Maybe with some zoning information. A point will come 5 years after that where those buildings are built and the shape of those like really simple shapes that they drew in those plans become buildings. Those buildings are put together with materials. And it's this translation between the abstract world of design and the real world of construction is really where the magic happens, all the way down to the small details, right? An architect will draw a wall section, and the way that wall section is drawn determines the labor that puts it together and the material supply chains that are mobilized to make it work. And what embedding carbon thinking and environmental sort of assessments in the design process allows us to do is understand how these small abstract gestures move up to mobilize. All the gypsum comes from somewhere, right? Wood comes from trees, it turns out. Steel comes from either primary materials or recycled materials. And the way architects make these very small decisions have world transforming consequences. And like you said, and used the word intention earlier, designing with intention, which is something people do on all sorts of kind of axes, is really the name of the game here.
I love how you've brought that together, though, because it's really important to think about where, small design changes or choices in the materials you plan to use or the equipment mean that, a ship that might not have come across the ocean to bring materials now does, because you require this. And all of this has implications that, like, we can't stop all of these choices and, go into decision paralysis, but it's very important to consider in the big picture. So I appreciate that level set.
One other point there, I think that is just like, again, one of these magic things is, we've really used to be in practice. Now we're very much in the software world. And in the software world, we talk to investors, we talk to other tech companies. There's been a fascination in the sort of tech space with this idea of bits that move atoms, things in the digital world that transform the real world. And I think in other disciplines, This is a rare thing to come by, but it is literally the day job of everybody working the space.
Yeah.
I think the digital future of design is being embraced by a wider kind of section of the industry. That there's a way where like the way literally data is managed, right, across AEC firms just is directly translated into real world impact.
And that's one of my favorite things about this industry, actually, is at the end of the day, something does get built. There is a tangible building in front of you, or a change to a facility, or a renovation. I remember the first time I'd won a big proposal at the first general contractor I had worked at. And then I had the opportunity to do a site walk on that project after it had started being built. And it was a really crazy experience for me, because that was at one point, it was like, okay, we're going through this 2,000-page RFP and put all these binders together, because I was working for the federal contractor at that time. And I just shipped the binders and then off the next RFP for a long time until I got a bit further down in my career. And to be able to walk up and go, there it is. Like, that really made me connect with the field teams and the project teams in a way I hadn't before, because I got to experience that. It was like, okay, I helped build that. And me as the proposal manager, obviously very small part in that, and hand over all these documentation. But like, gosh, that felt good.
And when we put another lens over to that, there is this moment that architects and contractors know and love, which is like seeing their baby.
Oh yeah.
Seeing the thing that they saw in a drawing become real. And then when we use things like lifecycle assessment to look at the lifecycle of a building, we also can consider in the same decision process, hey, what forest did these trees come from?
Yeah.
Right? Like an amazing example today is the Portland airport that was just finished. ZGF Architects, amazing firm.
It's beautiful.
And every bit of timber in that building was sourced responsibly. They understand where it came from. And I think that's a really beautiful story of how life cycle thinking isn't just math we do along the way, but it really can inform design outcomes.
And it turns into something that looks absolutely beautiful as well.
Right?
Like what a cool example of that. So I want to click in a little bit more in some of the challenges that organizations face when trying to monitor and reduce the carbon footprint of their operations. I know we've talked kind of high level so far. And so can we click down a little bit? Like, tell me how this just looks in the real world and the challenges folks are facing.
Yeah, this is where the rubber hits the road. When you need to implement a lot of these things, you're often working with not enough data. Generally, you are in a decision environment that's fast-paced, and you need to move quickly to make the right decision, because guess what? Any of this sort of decarbonization planning also needs to fit cost, schedule, right? Like design outcomes. And this really is, us at C.Scale, this has been a big focus of ours, is getting people the right data at the right time to make the right decision. Legacy processes for doing this sort of assessment really require the project to be complete before you can do the assessment. This is important because there is something about the backwards looking, hey, how did we do? What does this look like? But really, ultimately, what we focus on is moving decisions earlier in the design process and allowing people to make sort of like tactical decisions, directionally accurate decisions early in the game when these big decisions are being made and you don't have all the data.
Yeah.
Because that's just the reality, actually, of the design process generally, is you're always trying to look into the future. Design is always sort of speculative and projective, and figure out what could happen. What if we make this decision and not that one? By the time the decision is made, it's often too late, actually, to affect a better outcome.
It's exciting that there's more data available and more tools for folks to use in these processes than there has been historically as well. And I have a lot of empathy for folks using, traditional workflows, trying to track and manage and maintain all of this information, because it's like an extra layer on top of an already very complex process. And I think there's a mindset shift that's happening right now where folks are integrating this more intentionally and earlier in the way that you're sharing, which I really appreciate. But I'd love to click in a little bit more to understand, like, what is typically monitored or tracked with regards to the carbon footprint and emissions of a building or a construction project? And, what are those tools looking like that have done that traditionally?
Yeah, and this is when we start to think about, we're a tool provider, and there's a lot of other great ones out there too. And people ask like, oh, do you consider yourself competitive with this tool or that tool? Yeah, maybe in 10 years that's going to matter. But really our main competitor today is Excel.
That doesn't surprise me
right?
at all.
The core of so much of it is quantities and processes. And this is one sort of the major potentials we see in this analysis, is that to do life cycle assessment, you need to know what goes into the building. And knowing what goes into the building early and iterating on it as the design progresses is also important for things like cost, is also important for things like schedule or supply chain risk management. And at the present moment, this data is inconsistently tracked, is tracked for some disciplines and not for others. But lifecycle assessment requires comprehensive tracking of materials and processes. And so that's always the first layer, is just tracking what goes into the building. And then the second question is, well, where did that stuff come from?
Yeah.
Which energy are you using? Where are these materials sourced? And this starts to give you a couple different knobs and levers to play with in reducing the environmental impact of a building. First is using less. Second is using better materials. And this is where, we start to get into this richer data landscape where the first sort of bit of quantity surveying very much happens in digital design tools like Revit. And then the assigning of environmental product declarations, which really take a lot of the complexity of supply chain impacts and roll it into simple documents that you can reference to say, this steel from this manufacturer has these sort of aggregate impacts. You can start to map that to your design data to understand the supply chain impacts of those materials. To continue with the steel example, you have, say, steel moment frame in the building that's mapped to some steel supply chain data. And then you understand broadly what that impact is. And you say, okay, we could use less steel. We could maybe design a slightly different structure that is more materially efficient. What if we use a different supplier? What if we use steel from an electric arc furnace with a high recycled content rather than blast furnace steel that has more virgin iron in it? And these are the decisions that people get to start asking. And some of this people ask because clients are hungry for it. Other times it's regulatory pressure. Access to capital is a really big one. Actually, there's a lot of large European pension funds involved in construction in the United States that realize that as pension funds, they have a responsibility to the future of the fund in the long term. And they see addressing climate change as part of their responsibility in the way they manage their fund, right?
That's
Over
really
the
cool.
long term.
Yeah.
It's super cool. And these are realities in the design field in the United States today.
And I think through all of this as well, it appears that there's two kind of areas of data or information management, decarbonization, or at least that's what my inference is at this point. The need for reporting alongside the need to access data that influences decision making. And I'd love it if you could tell me a little bit more about your thoughts on the balance between both of these objectives. Are they complementary? Are they at odds? I think they both kind of touch on two different intents.
No, and I'm glad you're drawing out that dichotomy because they, while related, I do think they're different. Reporting and compliance is what you do when the project is over. And, in Boston today, you're going to have to start sending in a full life cycle assessment to get your permit. Well, by the time you're there, most decisions are made. The building's kind of baked.
Yeah. It's like, there it is.
There it is. This is what it looks like. This is how we did. And that's one sort of like data structure, reporting, and compliance framework that's super important. It helps the city understand what's happening. It helps them move that permitting process forward. The other thing, though, that's different is, and I think an exciting place for us to spend time is, well, what got you there?
Yeah.
Why does the final building look like that? Why did you use, right, like that steel moment frame instead of that sort of reinforced concrete structure? Hey, like that window to wall ratio, was it the right choice? When you think about the massing of the building, do you have a really squat, structurally efficient building? Do you have a very leggy, more expressive building? All of these have implications on the environmental impacts of the project. I want to build tools, and I think the industry needs tools to inform those decisions, like design decisions. The problem with these design decisions is that a lot is still unknown. You have not yet detailed, the deck, but you're trying to understand if that deck is better than that, like that alternate structure. And that's really where I see data, and especially I think in this day and age, machine learning and artificial intelligence playing a really important role in moving us from the practice of life cycle assessment that's really compliance focused to one that's actually integratable into the design workflows.
And I think all this does really come back to intent as well. And there's a lot of very deliberate choices that need to be made throughout the entire process of building. But I have empathy for folks who are trying to say, okay, we want to reduce this amount of carbon when we're building a new structure. But if all of these design details haven't been defined, and they're going to be defined during construction in some of our very fast to market building approaches, which are very necessary for client expectations and everything else, it's kind of an unwinnable problem in some situations. And so how do you get that level of certainty early on, but still have a schedule duration that meets the needs of your customers and clients, and it allows you to remain competitive as well? Because most folks do not want to sit in the design, bid, build, operate traditional approach anymore because it just takes too long.
Yep.
Even if you had more ability to offer certainty in these materials choices, because you've finished the whole design already and handed it over for construction, but gosh, that took a while.
Oh my gosh, no, now it really, like, the steel package has gone out to bid, right? Before the envelope is designed. Like, this is the way buildings are happening more and more.
Yeah.
Really fast, really dynamic, lots of, stacked processes. And this is where we get back to the kind of magic of abstraction that architects especially are really comfortable dealing with. Some things we know very well, like maybe we know enough about the steel package to send it out, get a bid, get it delivered. But we're still working on the envelope, but we know enough about it that we have it sort of like roughed in. We know where the connection points are, et cetera.
Yep.
The carbon models should run along the same trajectory. Where we have a lot of data, we can use a lot of data. Where we only have a little bit, okay, we're going to make some, we'll say like assumptions, fill in some gaps, use some inferences, the same way that cost models are done.
Yeah.
Sometimes you have all the unit costs. Sometimes you're using comps, right? In either case, it's all about having the full picture. The counterfactual here, really, to me, if we're not using data-driven methods to understand the whole project, is people are left guessing, or they are under the impression that they can do just half the math problem. We know a lot about the steel, so we're only going to look at the steel. And you get a very nice number, and it's very small, and you feel like you did a good job. But you've left a lot on the table, a lot of opportunities. So by using data-driven methods to look at the whole building and all of its impacts across all the supply chains feeding into it, even if some of that data is not yet primary data because the building is not designed, you're able to understand holistically what's going to matter most. You might find out that steel is actually per unit a relatively high impact, but because of the way you design the building, it's all envelope emissions. You don't know exactly what the envelope is yet, but you know that that's where you need to focus to make the biggest impact.
That's encouraging to hear. I appreciate that level set. And you mentioned something a moment ago about artificial intelligence, and I want to look a little bit closer at that aspect as well. So obviously AI is making a big impact on how teams tackle decarbonization. How's that showing up today, and where do you think it's headed in the future?
Today, I think there's two places where we really see it shaping the design process. I think people in AEC generally are getting more familiar, we'll say, with the idea of a technology stack.
Yep.
I think there's two, we see it at the very bottom of the stack. Us, for instance, we use a lot of like statistical models, machine learning to make better predictions of, say, structural quantities early in the design process. A lot of that is embedded. Those quantities are used in an early phase carbon calculation. And then the other place we see is at the very top of the stack, the way people are interacting with these models. We're really all in on trying to find multimodal ways of doing carbon assessments. We have our kind of classic SaaS product. We're working and actually just released to a beta group, an MCP, that allows people to interact with our carbon models through sort of a chat interface embedded in, whatever their sort of LLM of choice is. And I see the ways that people interact with this data changing as we move into an AI era. And I know I just have to put a little asterisk in here that there are obvious and real concerns about the impacts of AI and the environmental impacts and this feeling. And I think some of this critique is well-founded. Like, how do you use this thing that has such environmental impacts to forward sustainability outcomes? And for me, it's really about leverage.
Of course.
This year, say, the impact of AI and data centers is a little less than 1% of global emissions. It's probably a big number overall.
Yeah.
Okay, the built environment is closer to 40%. If we can achieve massive reductions in built environment emissions, leveraging data center emissions, I think we have the potential to do a lot of good in the world.
I'm inclined to agree. And I asked this question to Joe Spiker, Autodesk Chief Sustainability Officer, a while back, as far as the impacts of AI on the bigger sustainability narrative, because I admittedly was also a bit concerned as well. And his answer was really encouraging to me, where his take right now is it's both a headwind and a tailwind. And as the technology continues to develop, we have to push the initiatives that are sustainability driven, tied to AI technology, to ensure that it is going to continue to be an even bigger tailwind. And your data points that you just shared there really, I think, cement that, where while it's 1% of global emissions in construction, the built environment is 40, if that goes up to 3, but that 40 goes down to 20, like, that I'm not a mathematician, so I'm not going to try to make sense of that number beyond that. Like there's a reason why I didn't stay in engineering, but it makes sense in that moment. And so I'm cautiously optimistic, but there is a lot of work there. And I think there's a lot of change coming in the realm of AI, and the hockey stick is just, going up in a exciting and sometimes terrifying way.
May you live in interesting times, right?
Yeah, well, we're most certainly there at this point in our lives. Well, Jack, I'm curious, if somebody out there listening isn't sure where to begin their decarbonization journey, what advice would you offer them to get started now that they've gotten a bit of a primer on, what this concept means and how it can impact their business?
I think I would say there's two kind of tracks that are really important to move in parallel in terms of just how to get started. One is just start doing some analysis.
Mm-hmm.
We work with Autodesk Forma a lot on the carbon assessment there. It's great if you're in the larger Autodesk Construction Cloud, you have access to those tools. We have our own platform. There's a lot of other platforms out there that are easy to get started in, and just start somewhere, look at the numbers, ask questions. And that will, that'll start, that's one of the train tracks. The other train track that's so important is join communities of practice. So much of the knowledge that lives in the construction industry lives in people.
Yeah.
And my own career, the career of so many of my peers, are really transformed by plugging into communities like the one around us today at Greenbuild.
Yeah, what a privilege to sit down in a place like this.
It's amazing, right? Like, I have received so much mentorship myself, like hope to do my best to pass that on. And it's really just engaging with other people asking similar questions. This is the way to get up to speed quickly. So AIA Coat, USGBC communities, Living Future, all of it, Mindful Materials, these are all really, I think, generous communities where people can plug in, get started, ask questions, and hop on board. The water's warm,
I love that. I mean, the community in the AECO space is incredibly welcoming and willing to share, because I think folks really truly understand that we have to go at this together. The community is so critical, because one company, one country, one state, one building standard isn't going to change the world and how we approach all of the challenges that are in front of us. But I also love your point about just start. You have to get going, and it can be overwhelming. And the advice that I give to folks when they're overwhelmed by, starting a data strategy or data collection or whatever is, figure out where the easiest starting point is going to be for you. Where are you already capturing that data? Where are you already gathering information that will be relevant to this new goal that you're trying to achieve? And start there. Don't try to boil the ocean, because that'll, one, be very overwhelming. And two, it's going to slow, I think, your path to building a successful proof case to build with your team and say, look, we had this great win because we started small and very intentional. And then you expand that to the other aspects of your business as well. At the core of it, though, and the ADHD coach that I've worked with endlessly, she always just tells me, you just got to start. And that's very hard for me sometimes, but it's incredibly truthful information, whether, it's me trying to get my work done or my, dishes, or somebody at a business trying to decarbonize or reduce their emissions overall.
It's so real, right? It's just take the first step, find a friend, we'll go farther and faster together. And I think the other thing, just to harp on a point you made earlier, I mean, when I was in practice, we would compete ruthlessly against other firms to win projects.
Oh, I know that game as a formal proposal manager.
But then at the end of the day, whoever won, all of the sustainability leads at all the firms are talking to each other, because exactly this, competition on projects, cooperation on climate. We need the whole industry moving the same direction. And it is 100% the communities of practice that are really getting everybody on board. Whatever the project is, whoever won it in the end, we all want the same outcome.
Incredible message to close our conversation on, Jack. But I've got one more question for you today.
Please.
And that's, what's one tool that you use in every project, no matter what you're working on?
Well, it's funny for us moving out of being out of practice and into, now we're a software company. Mm-hmm. It's really changed our whole tool stack. I'll answer this in sort of a vague way, but I think communication tools remain the most important thing that we have. We really pride ourselves on having a culture. We'll chat a little bit, and then it's always okay, if there's any ambiguity at all, jump on a call, let's talk through it.
Yep.
And really trying to close communication loops is a really important part of working internally. And that's really, I think, definitive of our internal process and how we like to work together.
I like it. The communication, I mean, we don't get anything done unless we're able to be clear in what the expectations are and the goals are. And sometimes that's very hard to convey over a text message or Slack or whatever. So I'm very similar in that, hey, like, can we chat for a couple of minutes to figure this out? But I always try to be respectful. Like a couple minutes should be, 3 to 5 and not, oops, sorry, I've taken an hour and a half of your time. So we have to be intentional about how we collaborate together. But I think communication is a core of it, especially in such a complex environment. Like coming back to my example earlier of 20 or 30 or 40 specialty contractors and subs all working together in a single project. Like that doesn't happen successfully unless everybody is lockstep and communicating what their expectations are, when they're going to be there, and what their scope of work is. So I love that answer. It's great. Well, Jack, thank you. Thank you so much for joining me on Digital Builder. For everybody out there listening, I'm your host, Eric Thomas. If you're curious about our show and want to learn more, we're a video first podcast, so you can find us on YouTube. And of course, we're on Apple Podcasts, Spotify, and all those other wonderful places. We're having a lot of fun here at Greenbuild. And if you got any questions for me, you can find me on LinkedIn. I'm the only Eric Thomas that works at Autodesk. And until the next time, goodbye.